Hello students, welcome to online maths classroom. Today we are going to start with continuity and differentiability part 4, in which we will solve exercise 5.1 question number 22 to question number 34. So let us start with it. Question number 22 says discuss the continuity of cosine, cosecant, secant and cotangent functions. Okay, we have done in your example how to check the continuity of sine function. Okay, so today let us see how to check the continuity of all these rest of the functions. The tangent continuity has also been checked while solving an NCERT example. So fx is equal to cos x. Again, let's see is any real number because we are checking it for general real number. So function will be continuous at C when LHL means the left hand limit equal to right hand limit is equal to the value of function at C. Okay, so take the left hand limit. So limit x approaches to C from negative side fx is your cos x. Put x is equal to C minus h. As x approaches to C, h will approach to 0. So this becomes cos C minus h. Now what is the formula for cos C minus b? It is cos A cos b plus sin A sin b. So when you will put the limit 0 as sin C out, limit h approaches to 0 sin h, and plus cos C out, limit h approaches to 0 cos h. And you know that the value of sin 0 is 0 and cos 0 is 1. So we'll get it as cos C. Okay. Even if you don't want to go for say left or right hand limit separately, then also you can check only the right hand limit as we did in example where we check the continuity of sine function. Okay, but this is just for this explanation purpose that we took both. So taking right hand limit, again cos x x c plus h. Okay, and for right hand limit c plus h, h approaches to 0. The formula for cos a plus b is cos a cos b minus sin a sin b, and for this case also we get the value as cos c, and fx is cos x and fc is again cos c. So by putting in the first condition where LHL equal to RHL equal to f of c, as we are getting all the values equal, so that means fx is function for continuous for all real numbers. Okay, so cosine is continuous. Again cosecant x is your 1 upon sin x. Now let us see it as the numerator is as px as 1 and qx as sin x. Okay, now 1 is your constant function which is always continuous. Sin x you know is always continuous for all real numbers. Okay, so by algebra of continuous function, this fx is px upon qx is also continuous for all real numbers, but qx should not be equal to 0. Now I should check where this qx or sin x is not equal to 0. So sin x should not be equal to n pi. Okay, x should not be equal to n pi so that sin x does not turn to be 0. Okay, for n belonging to z. Okay, so cosecant is continuous for all real numbers such that x is not equal to n pi. Okay, the integral multiple of pi where n belongs to z. You know, at these values sine turns out to be 0, and for this 1 upon sin x will not exist. Similarly for secant x, 1 upon cos x, px1 is continuous, cos x is also everywhere continuous, but this whole function will be continuous if qx is not equal to 0, that is cos x is not equal to 0, that is x is not equal to odd multiple of pi by 2. So secant will be continuous when your x is not equal to odd multiple of pi by 2. Cot x is cos x upon sin x, again the same condition, numerator is continuous, px, the denominator is continuous. Okay, so by algebra of continuous function, this fraction will be continuous, but qx should not be equal to 0. And you know the condition for sin x not equal to 0 is x not equal to n pi. Okay. Question number 23. Find all points of discontinuity of f where sin x upon x, x less than 0 and x plus 1 for x greater than equal to 0. Okay. So you know that whenever we have to check the all points of discontinuity, or we have to examine the discontinuity or continuity, what we need to do is we check for all. Okay, so let us see first of all for x less than 0 the function is sin x upon x. Okay, so numerator is continuous, denominator is continuous, so the fraction is also continuous for x less than equal to 0. Okay, because x is not equal to 0 in this case. Okay, and now for when x is 0 I have to check both LHL and RHL as the function is defined differently. Okay, so LHL equal to RHL equal to f of 0. If it holds, then the function is continuous. So let us check. Now let us take left hand and right hand limits. For left hand limit x approaches to 0 negative side. Okay, you know how to do it. Put x is equal to 0 minus h. As x approaches to 0 from negative side, h will approach to 0. So f of 0 minus h is same as f of minus h. When put it in the function sine of minus h upon minus h. So this becomes minus times sine h. Okay, this is the odd function upon minus h. It gets cancelled. And previous year we have done in limits of result that limit h approaches to 0, sine h upon h is 1. Okay, so we get it as 1. Similarly for RHL, put x equal to 0 plus h. As x approaches to 0, h will approach to 0. So it becomes limit h approaches to 0, h plus 1, that is equal to 1. And again f of 0 is 1. So LHL equal to RHL equal to f of 0. So function is continuous at x equal to 0. Now for x greater than 0, function is x plus 1. And you know is a linear polynomial, so it will always be continuous. Okay, for even x greater than 0 also. Hence the function, it was defined for your 0, and we have to check whether everywhere it is continuous or not. So for all values x less than 0 it was continuous, at x equal to 0 it is continuous, and for greater than 0 it is also continuous. So there is no point of discontinuity. Okay. Again, the very important question is your fx is x square sine 1 upon x, x not equal to 0, and 0 if x equal to 0. Okay. So we need to find the continuity of the function. We have to check the continuity for different values of x, when x not equal to 0 and when x equal to 0. Okay. So when x is not equal to 0, your function is x square sine 1 upon x. You can see it is the product of two continuous functions. Okay. As x square is a quadratic polynomial, everywhere continuous. Sine 1 upon x, again sine function, is again continuous. So it is always continuous for x not equal to 0. Now see what is happening at x equal to 0, because the function is defined here for checking the continuity. Okay, so when x is 0, function is, I have to check the left limit, right limit, and the value at f of. So see the left hand limit. Now this is very crucial part. Please concentrate. Put again x equal to 0 minus h. As x approaches to 0 from negative side, h will approach to 0. That is f of minus h I have to put. So the function was x square sine 1 upon x. So I get it as minus h square, h whole square sine 1 upon minus h. Okay. Now here you can see in right hand limit also same situation will be there. Just there is minus h, there is plus h. Okay. Same condition is there. Now what is going to be here? If I put the limit directly, see, this is very important. See, if I put the limit directly, what is going to happen? Do you think it is turning out to be 0? If you think, you are wrong. Why? Because say, I'll put the limit h as 0. See, it will become 0, no problem. Sine 1 upon 0. Sine 1 upon 0 is infinity. And what is sine infinity? See, 1 upon 0 means the angle is infinity. Sine infinity is infinity. And 0 into infinity is not 0. It is undefined. Same case is happening here. If I'll put directly 0, then it will be 0 into sine 1 upon 0, that is sine infinity, that is infinity. Okay, so that is undefined result. I don't want to go for it. Okay, I don't want the undefined result. I have to get some valid value. Okay, so see, I cannot put here the limit directly. You know the rule that while we studied the last year limits also, that you have to save the things from becoming to infinity. Okay, so I cannot directly put. So now how will I solve? Do you know that this value, okay, this is sine function, whether it is positive, whether it is negative, it is a sine function, and you know the value of sine theta always lies between -1 and 1. Okay, it's always an oscillating function between -1 and 1. So whether it is sine theta, whether it is sine of 1 upon minus h or something, I'm not putting this limit minded. Okay, you see, whatsoever angle this sine is there, the value is coming out to be between -1 and 1. Okay, that is the sine of 1 upon minus h. It is having some finite value which is oscillating between -1 and 1. Okay, and let I give it a value as k. Okay, let it be k. Okay, so now I can put the limit. So 0 square into k is now turning out to be 0. No doubt the result is turning out to be 0, but dear students, I must keep it in mind. I cannot put the limit here directly as 0, because in that way the result is turning out to be undefined. Okay, same case is here. You will write it as h square into k. Okay, as the sign of something is an oscillating function between -1 and 1, so have a finite value. So 0 into a finite value, that means 0. In that way it gives you the value same, and f of 0 is 0, LHL equal to RHL equal to f of 0. So function is continuous at x equal to 0, and also for all real values of x. Number 25 says, examine the continuity of the function defined by this. Okay, sin x minus cos x, x not equal to 0 and x equal to 0. Okay, so when x not equal to 0, fx is the difference of two continuous functions. Sin x is continuous, cos x is continuous, and the difference is also continuous. So fx is always continuous for x not equal to 0. Case number 2, when x is equal to 0. So when this x is 0, fx, I have to check the continuity. So again, I'll apply that LHL equal to RHL equal to f of 0. Okay, even I can go for this right hand limit also only, but let us check it for both ways as I'm examining. Okay. So see, for left hand limit, it is f of minus h. So it is sine of minus h minus cos of minus h. So it becomes minus sine h, as sine of minus theta is minus sine theta, and cos of minus h is plus cos theta. Okay, so it becomes minus sine h minus cos h. Okay, so when I'll put the limit, sine 0 is 0 and cos 0 is 1, so it turns out to be minus 1. Similarly, this way, f of h is sine h minus cos h. So this is 0 and cos h 0 is 1. So I'll get it as minus 1, and f of 0 is also minus 1. So LHL equal to RHL equal to f of 0. Function is continuous for all real values of x. Number 26. Okay. Now find the values of k so that function is continuous at the indicated points. Okay. So see, when will the indicated point means? Here it is pi by 2, as fx is your k cos x upon pi minus 2x for x not equal to pi by 2, and 3 if x is equal to pi by 2. Okay, so function will be continuous. It is given that it is continuous. You have to check the value of k. So continuous means that left hand limit equal to right hand limit equal to f of pi by 2. So I'll get all the values and put it in here in this equation, and I'll get the valued value of k. So left hand limit is again x approaches to pi by 2 from negative side. So what should I put? X as pi by 2 minus h. Okay. So when I'll put here, it will become k cos pi by 2 minus h upon pi minus 2 times pi by 2 minus h. Now be careful here. Okay. See, the numerator will become cos 90 minus theta is sin theta, and denominator says pi minus 2 into 2 gets cancelled. So it becomes as pi minus pi, and multiply this. Don't forget to multiply this minus 2 inside here. Okay. So it becomes plus 2h. So it gets cancelled. So it is k sin h upon 2h. So keep this k by 2 outside, as it is a constant, and rest result is your limit h approaches to 0 sin h upon h is 1, which is k by 2. For right hand limit, put x equal to pi by 2 plus h. Again k cos pi by 2 plus h. Denominator is turning out to be same, but here this denominator will be minus 2h, and numerator is your, as again sine of cos 90 plus theta is minus sine theta. So this negative can be balanced, and it also turns out to be k by 2. Okay, so there was no need of doing. That's why for x not equal to pi by 2, you can simply go for this right hand limit unless until it is a modulus or greatest integer function. Okay, and f of pi by 2 is also 3. So by putting it here, I'll get k by 2 equal to 3, that is k is equal to 6. Number 27 says, again for kx square for x less than equal to 2 and 3 for x greater than 2. You have to check the continuity, means the function is continuous at x equal to 2. You have to find k. So again, LHL equal to RHL is equal to f of 2. So LHL will give you the values as, say, k into 2 minus h whole square, that is 4k. RHL will give you the value as here RHL is always 3. Okay, as there is no x, so you cannot replace f of 2 plus h anywhere, so it is just 3. Okay, so again what is f of 2? F of 2 is again your kx square. Kx square means it is again 4k. Okay, so when you will equate all this RHL equal to LHL and your this value of the function at 2 also, so it will become k as 3 by 4. Okay, for number 28, again kx plus 1 for x less than equal to pi, cos x for x greater than pi. Okay, so again the continuity, when LHL, it turns out to be k times pi minus h plus 1, so it is k pi plus 1. RHL is f of pi plus h, so it will become cos of pi plus h, and when I'll put the limit, okay, either I can just change to say 180 plus theta also, that way also, but when I'll put it as 0, I'll get it as cos pi, and cos pi is your minus 1. Okay, so when I'll equate it, both of them with f of 0 as the less than equal to pi case, here fx is your kx plus 1, and when you will put for f of pi, you will get the result as k pi plus 1. Okay, so all of them when equated together will give you, okay, you can just, that's why go for LHL equal to RHL case also, you'll get the value of k as minus 2 upon pi. Number 29 is again a simple question. X less than equal to 5, this function is there, and for x greater than 5, 3x minus 5. So again, since the function is continuous, LHS limit at 5 equal to RHL limit at 5 equal to f of 5. Okay, so put f of 5 minus h, I'll get it as, this is the defining for less the case, k of 5 minus h, this is your 5k plus 1. Similarly, your f of 5 will also be 5k plus 1, and the right one is your 3 times, say 5 plus h minus 5. Okay, you have to put x equal to 5 plus h. So this becomes 3 times 5 minus 5, that is again 10, and equating both of them, you will get k as 9 by 5. Question number 30. Find the values of a and b such that function is defined by this is continuous function. Now you know that I have to check that the function will be continuous at x equal to 2. I have to check when LHL equal to RHL equal to your f of 2, and again at 10 also your LHL equal to RHL equal to f of 10. So at x equal to 2, say the left limit is turning out, this is the condition, LHL equal to RHL equal to f of 2. LHL will give you 2 f of 2 minus h is again 5. Okay, for less than 2 it is 5. For right hand limit it is your, okay, a times, you will put, replace x when x approaches to 2 from positive side. Okay, h will approach to 0, so f of 2 plus h will give you a times 2 plus h plus b. So after applying limit, I get 2a plus b. So I will get 2a plus b equal to 5. Okay, because your, and it is equal to f of 2 is again 5. So I'll get the first condition like this. Similarly for 10, when your this function at x equal to 10, it is also continuous. So again LHL equal to RHL equal to f of 10. At x approaches to 10, it turns out to be 10a plus b, and for right hand limit it turns out to be 21, and f of this your 10 is also 10a plus b, okay, equal to 21. This is the condition I'll get, and again for solving number 1 and number 2, I'll get the value of like linear equation in 2 variables. Okay, simple subtraction will serve the purpose. There is no need to go for this substitution method. You will simply get by subtraction a as 2 and b as 1. Okay. Question number 31. Now you know that the composition of two continuous function is also continuous. So let us see. Show that the function defined by fx equal to cos x square is a continuous function. Now you know that this is not a simple function, it's a composite function. Now let us see how it is a composite function. Let gx is equal to cos x. Okay, this is the combination of two functions, one the trigonometric cos and other the polynomial, quadratic polynomial x square. So gx is cos x and hx is x square. So what is goh of x? It is g of hx. I'll just check whether it is the composition of these two functions. So g of this is a mandatory part to be proved before checking the continuity of such functions. G of hx, okay, by the definition of composite functions. So g of hx means g of x square, and I'll put x square at this gx and I'll get it as cos x square, which is again your f of x. So your fx is g of hx. Now gx is equal to cos x. You know cos x is everywhere continuous, and x square is being quadratic polynomial always continuous, and the composition of two continuous function is continuous, hence this function is also continuous. Similarly for 32, again I have to check it is the composition of two functions, one the trigonometric, other one is the modulus. So let gx is mod x and hx is cos x. Okay, so g of h of x is g of hx, that is g of this cos x, and this cos x inside this mod will give you mod cos x, which is your fx. Now again mod x is everywhere continuous, hx cos x is everywhere continuous, so composition of two continuous function is continuous, that's why this is also continuous. Number 33 says sine of mod x. Now let us check. Gx, two functions are there, one is sine, other one is modulus. So gx is sine x, hx is modulus x. So what is g of h of x? Okay, it is g of hx, that is g of mod x, that is put this mod x to this function, so it becomes sine of mod x. Okay, g of mod x. Okay, so it is fx, and again this sine x is continuous, modulus is continuous, and the composition of two continuous function is always continuous for all real values of x. Now question number 34, it is a very important question. See, this question can be done in simple ways also, but this question is done elaborately. The 2-3 things are there, 2-3 factors are there that you should know how to define the modulus functions. Okay, how to when the conditions of mods are there, how to define the function. Okay, for various conditions. Okay, so first thing is I should check, as it is the difference of two modulus functions. Okay, so I have to check the points at which these individual functions become 0. So this becomes 0 when x is 0, and this becomes 0 when x is minus 1. So these are called the two critical points, and this concept you will be having cleared in your differentiation topic. Okay, so the 2 points where it turns out to be 0 is x0 and x minus 1. Okay, so my intervals will be your, how will I check? Means minus 1, say minus 1, 0. Okay, so I have to check for less than minus 1 also, between minus 1 to 0 also, and your greater than 0 also. Okay, so see how I am going to define it. When x is less than or equal to minus 1, the first case, see fx is your mod x minus mod of this. Okay, this is your, now mod x, you know, it is x when x positive and minus x when x negative. Okay, and what about mod of x plus 1? This is plus when this x plus 1 will be greater than or equal to 0, that is x greater than or equal to minus 1, and it will turn out as minus times itself, it is x plus 1 is less than 0. Okay, the same case, that is x is less than, okay, minus 1, x is less than minus 1. Okay, so now what do I say? That for x less than or equal to minus 1, say less than or equal to minus 1, the condition for less than or equal to minus 1, okay, as it is less than 0, the case is this is also negative, means minus x, and this turns out to be also negative. Okay, for less than or equal to minus 1. Okay, so this will become as minus, it will come outside as minus times. So it is minus of this plus x plus 1, that is fx is 1. Okay, so that's why function is 1. This is how we frame the questions, means the conditions, how the function will be defined. Fx is 1 when x is less than or equal to minus 1. Second case is between minus x, minus 1 and 0, means x greater than minus 1 and less than or equal to 0. Again, now what is the case? It is greater than minus 1 but less than 0. Okay, so the case of less than 0, say again this is negative, so it is minus x. Again this is your positive, The second one, x plus 1 is positive. Okay, because for x less than equal to 0, it is turning out to be positive. Okay, less than equal to 0, as it is the case of, say, the second one. Okay, less than equal to 0 means the case of this minus greater than minus 1. So it will turn out to be as plus x plus 1. So it will be your, as this sign is negative, so it is minus times 2x minus 1. Okay, so the function is defined this when it is like between minus 1 and 0. Okay, the third case, when x is greater than equal to 0. Okay, positive, for both positive, this is positive. Again, for this positive case, this is again positive. So it is x plus 1. So I'll get it as minus 1 when x is greater than equal to 0. Now this my function is now defined. Now let us check the continuity. So where should I check? I'll check it as less than minus 1, at minus 1. Okay, I'll check it greater than 0. All these conditions will be there. Okay, so let us one by one check. For x less than minus 1, your function is 1. It is constant, so continuous. So fx is continuous. What about at x equal to minus 1? You know, at x equal to minus 1, the function is defined both ways. Okay, so I will check again left limit equal to right limit equal to f of minus 1. So let us see the left limit at minus 1. Minus 1 approaches to negative side, f becomes it as minus 1 minus h. So it is again 1 for right hand limit. Okay, it becomes as minus times your 1 plus h. Okay, minus 1 plus h. So put it in the function. So I'll get it as minus 2 times this minus 1. Okay, so this becomes 2 minus 2h minus 1, and it turns out to be your 2 minus 1, that is 1. Okay, and f of minus 1 is also 1. You see, all of them are same. So function is continuous at x equal to minus 1. Okay, case number 3 is your when x is greater than minus 1 but less than 0. Okay, so function here defined between this range is minus 2x minus 1, which is a linear polynomial, hence everywhere continuous. Fourth case is when x is 0. At x equal to 0, again you have to check the left limit, the right limit. Okay, so when you'll check the left limit, it is minus 1, right one is minus 1, f of 0 is minus 1, so function is continuous. And what is happening for x greater than 0? It is again minus 1, again a constant function is continuous. Okay, so as we see, wherever I have checked, okay, howsoever the function was, as it was an open question, mod x minus mod of x plus 1. Okay, if it is a 1 marker, 2 marker question, I'll simply write that it is the difference of two continuous function. So it is always continuous. But if this question comes in elaboration, I have to define this question as well. Okay, and I have to, this question also gives you the idea how we conclude that modulus function is behaving continuous. Okay, so the different conditions, the various conditions we framed, we just concluded that this behaved as a continuous function, and the difference of two continuous function is always continuous. Okay, so there is no point of discontinuity, therefore f is continuous for all x belong to R. Okay, I hope this topic, these questions are clear to you. Okay, so prepare it well, do it well, take your pen and paper with you, do them again and again, understand the concepts, and the things will be clear to you. Thank you.